All right, y'all, what's happening? It's the Network Ninja back with another video trying to get up in them algorithms. Anyways, I remember when I first started, one of the hardest command outputs to understand for me as a beginner was the output of show interfaces command. So in today's video, I'm just going to be breaking down the output, basically telling you all the relevant information that I use when I'm troubleshooting or when I'm looking at the output of this show interface command. All right, so let's get started. So here we are in the switch. So if I do show interface FA0/3 right here, all of that, it's so much output, as you can see, that I have to hit the space bar. So to start off, the first part you want to look at if you're trying to break down this command, the first thing that I check is the status, because right here is going to give you, on this first part of it, is your of the OSI model, right? This is going to be physical layer, and then right here is going to be layer 2 or data link layer. So that's the physical layer, and then the data link layer, the the OSI model. And why that's important, right? Because physical layer, if this is down, I'm going to ask, is power and cabling been verified on the other end of this switch port, right? But now what if that line protocol is down? That's not going to be a lot to do with anything as far as your Ethernet connection or anything. That's starting to become logical. And when you're looking at layer 2, most of the time there's mismatches with serial connections that I see here. So your PPP might be PPP on one side of the interface, and then the other one might be configured as HDLC. So if your line protocol is down, start looking at your layer 2 encapsulations, whatever it may be, HDLC, PPP. If you don't know what that is, definitely look it up or drop it in the comments if you want me to do a video on that. All right, next thing, you can skip all of that right there. The next thing that I would check most importantly is this. And this is a good example because it's in auto duplex and auto speed. And what does that mean? It means that it is set to auto detect the other end of the connection. So whatever is connected on the other end is going to automatically detect whatever that speed and that duplex setting is. But the caveat with that is it's only going to sync up with the other side if the other side's set to auto. So what happens is if you have one side hard coded as full duplex and you have another side coded as just being auto, what will happen is the side that is configured to be auto, it will default to using half duplex, which will cause a duplex mismatch, which will cause a whole bunch of errors. Then it'll cause performance issues and everything like that. So best practice is to not use anything with auto set to it. You want to hard code everything just to eliminate that as a possible issue. So with this one, it should be hard coded, but it is set to auto right now, again, because this is a lab environment. But if this was real world, it should be hard coded. And that's the first thing that I'm going to look for. Even if they're saying, no, it's been working like this for years, I'm still going to say, let's try it out with it hard coded. And 9 times out of 10, hard coding it is going to fix the issue, whether it's performance related or anything. No, that was long-winded, but I think it was necessary because this is where a lot of stuff you want to check on the exam, in real life, when you're troubleshooting switch interfaces or interfaces in general, are these speed and duplex mismatches. I don't think I could say that enough. All right, moving down, the next piece we want to look at right here is last clearing of show interface counters never. This is a great command, or this is a great line of output that I use, because if we take a look at this switch right here and we do show ver, as you can see, it's been running for 4 days. It's been up for 4 days. I've been in switch environments where there's been switches up for 10 years, 15 years. There's been Cisco equipment up for many years, right? So let me run the command again so you can see it. So last clearing the show interface counters never means that these counters were, the last time they were cleared was ever since this switch has been up for 4 days. So if you see this and your switch has been up for 14 years, then you know nobody's cleared these counters. So you have no idea of whether these counters down here, these error counters, are relevant or not because the switch has been up for 4 days. You don't know when those errors came in. But if you clear the interface counters and then you run the command and you start seeing certain ones increment, like the broadcast increment, the multicast increment, or something like that. Now you can start troubleshooting because you have a good baseline. But without doing that, you have no way of telling. So you definitely want to pay attention to that line when you're analyzing this output. All right, the next line right here is the input Q and the total output drops. This I never really use in the real world. Also, they don't really hit it hard on the test, but we'll go over it because it is good to know. All this is definitely just the ASICs of the switch. And what I mean by the ASICs is that's the technology that Cisco uses. It's switching the frames or the data at a hardware level. And I guess that's why they're beating out a lot of people, right? It's not happening at a software level. So this thing is happening super fast. And that's what this input Q is. So you should never have anything like increasing in here, because if you do, there's definitely an issue, because it should be switching. This thing should be empty all the time. And if you're having output drops, then that's a good indication of some kind of speed or duplex mismatch, because again, this is speaking to the switching of the data of everything of your traffic. And if you're getting output drops, what could happen is if the other side is set to half duplex, that means that it is only going to transmit or receive. It's not going to do both at the same time. And if you're sending a continuous stream of traffic because you're full duplex and you can send and receive at the same time, some of your traffic might not make it there because the opposite end in half duplex may be transmitting at the same time you're transmitting, and it can't receive at the same time you're transmitting, which will cause that piece of data from your end to drop until both of you guys sync up to where it's communicating two-way at the same time. Hopefully that makes sense. All right, the next piece just dropped down right here, 5-minute input and output rate. You don't really need to worry about this. This is just really seeing if there's any traffic flowing across the interface. This is the last 5 minutes something came in, and the last 5 minutes something came out. It's good to check if you're looking at, or if it's two-way traffic, but if something's wrong with this, just throw the whole switch away at this point. There's not going to be like configuration or something that's going to be able to help fix that. It's just probably outdated iOS. Something's wrong with it, corrupt, something like that. So that's what I would focus on with this, just to see if I got two-way communication. Now, this is all of this down here. This is the part that you really want to pay attention to as far as when you're troubleshooting, because this is going to give you a lot of information. So right here, we're going to start with broadcast. If you see broadcast just incrementing, just a whole bunch just running, and everything else is zeroed out here, you want to start thinking of broadcast storms and possible loop issues, which is crazy because TP should be taking care of all your loops. So there might be a misconfiguration or something like that. But that's a good indication that there is a looping issue or some kind of broadcast storm if just your broadcasts are going up and no input errors or no overruns, nothing else is going on. It's just really broadcast being the dominant errors. All right, the next thing you want to check for is runts, if any runts are coming in. And these are just packets that are shorter than what the standard packet size is. I think it's like standard for any kind of Ethernet packet frame is 1518, right? So if you're coming in shorter than that, you're going to be considered a runt. And that's going to cause issues, right? Because you're not getting all of the information. It's short. It's not everything that you need. And again, that goes back to if you're seeing a lot of runs, I'm going to start thinking duplex mismatch first, because what can happen is, again, that half duplex is trying to talk and receive information at the same time, and it can't. So some of the stuff is going to make it back to you and some of it's not. And it's going to be just, it's going to be able to say, oh, I got some of that conversation and send you short part of it, which is a runt. So that's definitely not going to help you out. So if you're seeing a lot of runts, look for any kind of duplex mismatches. That's one thing that I would check for. Just want to hard code everything if stuff is set to auto again, just as a reminder. All right, the next thing, if you got runts, you definitely got giants, and giants are going to be packets that have a bigger packet size than the standard, which was 1518, right? You can see it right here. The standard is MTU 1500 bytes, and then the 1518 is like whatever, like I don't know down to the nitty gritty what it is, look it up, but it's a good size packet is 1500 bytes, 1518 or whatever, right? So again, if you got a giant, it's coming in bigger than what that switch interface can handle, and it's causing errors and performance issues and everything like that. So some networking environments, they need this. Storage environments need giant frames for whatever kind of storage to improve performance and everything. So it may or may not be a good thing. You just need to check on what's going on. Or sometimes it can be a result of a misconfiguration. This is what I would see a lot, again, is this MTU size, but this would be on a tunnel interface. And again, just because a tunnel interface is a virtual interface, it still has a certain MTU size. And when you add any kind of header information to a packet, which you do with a tunnel, that's adding extra information to the packet. So you're going to have to compensate for that if you're building out a tunnel and adjust the MTU size to something smaller than what I think it's like a 26 byte header that it adds on there. So you just drop it down to like 1420 or something. That way it'll fit through that tunnel interface, the amount of data. So hopefully that makes sense. If you got a giant, I would look at it. Definitely if you're on the tunnel interface, look for MTU mismatches, which again is right here. This MTU, you'll see that, and you'll be able to configure that. That's a configurable size. Finally, I don't really see it on the output of this switch. I don't know, I guess it's the iOS, but if you see collisions or any late collisions, again, look for speed and duplex mismatches. That's why I said this is probably the most important thing that you want to check on. Definitely if you're on the exam, you want to make sure that they're talking about if everything, the speed and the duplex is matched up and all of that kind of stuff. But if you see collisions or late collisions, that could be a good indicator. You have definitely input errors. A lot of this stuff, if you're having a lot of runs, you're going to have input errors, or if you're having a lot of overruns, you're going to have a lot of output drops and stuff like that. So some of these correlate with other things that I've seen, but what I've gone over today, just pay attention to those. Mostly that's what you're going to be running into on a day-to-day basis when you're working in the field, or as when you're on the test. Those are mainly the things that I would be cluing into to try to see, because they're not really going to test you on what input errors are, right? Rather than testing you on what runs are. All right. Thank you for tapping in with me. If you made it to the end of the video, I appreciate that. And make sure you subscribe, because if you like this video, how I broke everything down, I'm going to continue to do the same thing with all of these Cisco exam topics. Next time, I'm probably going to go over error disabled, or I might go over how to troubleshoot IPsec tunnel, because that is one of the things that I found very hard as well, was troubleshooting these IPsec tunnels, whether it's a site-to-site VPN tunnel or a DM VPN tunnel. It doesn't matter. I just want to go ahead and share that with y'all. So again, comment, subscribe. Definitely let me know what y'all thought in the comments, and I'm gonna holler at y'all on that next video. Peace.